Hi everyone, this is Sandeep Sharma, Electronics here, and welcome to yet another video in the Raspberry Pi and Arduino playlist. This is going to be a short video explaining about some of the differences between Arduino and Raspberry Pi. We have already learned about Raspberry Pi and Arduino boards in somewhat detail in my previous videos, so this is going to be a really brief summary for all of that. Both Arduino and Raspberry Pi have their advantages and shortcomings. Based on our task and objective, we should choose among these two types of boards. Where Arduino is more suited for controlling connected hardware, Raspberry Pi is suited for tasks which require higher computational power. Although there might be some tasks which can be done with both boards and some which might require both. Arduino is better suited for performing tasks involving analog input and control motors, interfacing with sensors, and real-time control. Here, by real-time control, I mean, let's say there is a requirement to send a signal to an external peripheral at certain intervals. The Arduino, since it's running a single program, will make sure that signal is sent almost after that time interval repeatedly. But in Raspberry Pi, this task will be given to a scheduler, which will try its best to execute this command of sending the signal, but it's not a guarantee. So basically, it's better to use Arduino whenever we need to work with a hardware component. Raspberry Pi, on the other hand, offers many possibilities in terms of software. We can write programs in a language of our choice, we can control a camera, we can make use of computer vision, AI, machine learning, etc. We can also run multiple programs at the same time. Having said this, there might be projects which require both a high computational power as well as good hardware. So we can use both Arduino as well as Raspberry Pi boards in such projects. Arduino is an open source project. Both its software and hardware design are open source, whereas Raspberry Pi is open source but only for the software side of it. The hardware side is a closed source. The IC for the control unit in Arduino comes from at Mega, which is at Mega 328P, whereas in Raspberry Pi the core is Cortex A72 ARM V8 64-bit and the SoC is Broadcom BCM2711. The clock frequency in Arduino is very much less than Raspberry Pi, which is 16 MHz in Arduino Uno, and in Raspberry Pi it can go up to 1.5 GHz in Raspberry Pi 4B. Arduino is based on a microcontroller, whereas Raspberry Pi is a microprocessor. The CPU architecture in Arduino is 8-bit, whereas in Raspberry Pi it's 64-bit. So an Arduino board uses 8-bit data bus, whereas a Raspberry Pi board uses 64-bit wide data bus, and therefore it can access 64 bits of data in a single machine instruction. There is 2 KB RAM in Arduino, whereas Raspberry Pi has more than 1 GB of RAM. If you have been using Arduino boards which are older, you probably won't find any Ethernet module on it, so you won't have internet access using Arduino. You will have to buy an additional module or a shield to connect it to the internet. But recently, Arduino has been releasing versions of boards with Wi-Fi and Bluetooth module as well. On the other hand, Raspberry Pi has a built-in Ethernet and a Wi-Fi support module. Another difference between the boards is that how they handle power drops. Arduino devices begin executing code as soon as they are turned on. Therefore, when the power is turned off abruptly, you won't find any corrupt operating system or errors. The code will just start running again from the beginning as soon as the power comes back. Whereas Raspberry Pi requires the same care as a PC. You will have to follow a proper procedure to shut the operating system down. As we discussed before, Arduino is used to perform a single task many times. That is, it can run a single program at a time, whereas Raspberry Pi is multitasking. It can run multiple programs together on top of an operating system. Another minor difference is that Arduino has a relatively simpler hardware structure as compared to Raspberry Pi. We can use C and C++ language to program Arduino boards, whereas Raspberry Pi uses Python and Scratch as the main programming languages, along with support for many other languages. Because of the complexity of hardware and the purpose of both the boards, Arduino boards are cheaper than Raspberry Pi, which are quite expensive. Also, an Arduino board consumes about 200 megawatts of power, whereas a Raspberry Pi board can consume up to 700 megawatts of power. Arduino board has been designed to control the electrical components mainly, which are connected to its circuit board, and Raspberry Pi boards compute data and produce valuable outputs and control the components in a system based on the outcome of these computations. So all the applications which are software reliant use Raspberry Pi. At last, to name some of the examples where these boards are used, Arduino is used, for example, in smart homes, in defense, in industrial applications, traffic signal control, medical applications, in laboratories for experiments, then sometimes in aerospace also, and automatic vehicle control as well. And Raspberry Pi is used in education, home automation, then it's also used for industrial automation as commercial products, individual projects. They are also used in security, in some TVs, to monitor weather, as bots in Twitter, then as file storage servers for music streaming, and many more. So, in many ways, it's similar to Arduino, but there are applications which I mentioned just now where Arduino cannot be used because of the complexity of the task. So, it's best to note down the requirements of a project, of a task, and then choose the board accordingly. If a task requires that our hardware operates smoothly, correctly, and at a proper time, then we should use Arduino. And if our task requires heavy computations on the software side, then we should use Raspberry Pi boards. We are at the end, and this concludes the differentiation between Arduino and Raspberry Pi boards. This was a very short video just summarizing whatever we have learned so far. In my next video that I will be uploading in some weeks, we will see a project that has been completed using Raspberry Pi board. Thank you all for listening. And if you liked the video, please don't forget to like, subscribe, and press the bell icon to get regular updates. This is Sandeep Sharma, Electron X. Thank you and have a good day.